You know, for years, the whole story in AI was pretty simple. Bigger is better. It was an arms race to build the largest models possible, a total brute force approach to creating intelligence. Well, that story is starting to fall apart. Today, we're going to break down how two new, much leaner models just completely flipped the script.
And look, that's not just hyperbole. The game is genuinely changing right before our eyes. What we're seeing is this fundamental shift, where the real breakthroughs aren't just coming from throwing more and more computing power at the problem. No, they're coming from smarter design, more clever training, and a real focus on quality over just sheer quantity.
All right, first up, let's talk about a model from Baidu called ERNIE 4.5. Its whole philosophy is about working smarter, not harder. So think of it less like one single giant brain trying to do everything at once, and more like a highly specialized team of experts. This whole idea? It's called a sparse approach.
And this is the core concept behind ERNIE, something called a mixture of experts architecture. So instead of firing up the entire massive network for every single calculation, which you can imagine is slow and super expensive, a smart router in the middle intelligently picks only the exact experts needed for that specific task. The result? You get incredible efficiency.
And this chart just shows you exactly how efficient we're talking. Yeah, the model has 21 billion total parameters, which sounds huge, but just look at that tiny activated slice. At any given time, it's only using about 3 billion of them. This is its secret weapon, how it delivers the power of a much bigger model while staying incredibly lean and fast.
And ERNIE's efficiency isn't its only trick. It's also got this, a massive 131,000 token context window. So what does that actually mean? Well, it means ERNIE can basically process and remember an entire book, or a really long, complicated conversation without forgetting the details from the beginning. That's a huge leg up for complex jobs.
So, the big question, does this whole specialist team approach actually work? Well, the numbers don't lie. Here we have ERNIE, the smaller model, outperforming a competitor that has 30% more parameters on a really important reasoning benchmark. This is just concrete proof that a smarter architecture can absolutely beat raw, brute force size.
So let's just sum it up. ERNIE is super efficient, it has that huge context window, and it can even use other software tools right out of the box. But maybe the biggest deal of all is this. It's open source. I mean, in a world full of closed-off proprietary models, making this kind of technology available for anyone to use and build on is a total game changer.
Okay, let's switch gears and look at our second challenger, which takes a totally different path to get to that same goal. This one is called K2 Think. So if ERNIE is the specialist team, K2 Think is more like taking a really solid, medium-sized model and putting it through the most intense, elite training regimen you can possibly imagine. So here's how they do it.
They start with a pretty capable 32 billion parameter model. Then they layer on this really intense, multi-stage training pipeline. First, they teach it to think step by step. Then, they use this new kind of reinforcement learning. And finally, they actually teach it to plan before it gives an answer. Each step just forges it into an even more powerful reasoning engine.
And this right here, this is the secret sauce. Instead of just rewarding the model for answers that sound correct to a person, they reward it for answers that can be mathematically or logically proven to be correct. This creates a much stronger, more reliable way for the model to learn, and it stops it from just learning how to sound convincing.
And here's another really clever trick they use. When you ask K2 Think a complex question, it doesn't just start spitting out an answer. First, it generates a quick plan, like an outline, and then it writes the full answer based on that plan. It's literally thinking before it speaks, and the result isn't just more accuracy, it's also, surprisingly, shorter answers.
And the results are just wild. K2 Think is crushing it, getting top-tier scores on some of the toughest benchmarks out there for math and coding. But the really shocking part is that third column. While it's getting the right answer, it's making its responses shorter and more to the point, getting more accurate and more concise at the same time. That almost never happens. It's incredibly powerful.
So what we have here are two totally different philosophies, two brilliant but distinct strategies, and they're both arriving at the exact same destination: top-tier AI performance without needing a gigantic, resource-devouring model to do it.
Let's just put them side by side. ERNIE innovates in its architecture, the what, using that sparse mixture of experts design. K2 Think, on the other hand, innovates in its training, the how, with its elite multi-stage pipeline. Both are open, which is amazing, but K2 Think even goes a step further, releasing not just the model, but all the training data and code. That's full transparency.
Okay, so let's zoom out for a second. Cool tech, right? But why does any of this actually matter beyond the technical details? Well, because this trend has massive implications for the future of AI, and honestly, for all of us.
This isn't just some academic curiosity. It's a huge signal of a major shift. We are moving into an era where cutting-edge AI is way more affordable to run, much easier to access, and can be used by developers and businesses everywhere, not just by a handful of tech giants with unlimited budgets.
So the takeaways here are crystal clear. Smart design is starting to outperform raw size. Efficiency is the new frontier where all the exciting progress is happening. Open source models aren't just playing catch-up anymore. In a lot of ways, they're starting to lead. And it all points to one thing. Powerful AI is finally, truly becoming accessible to everyone.
Which leaves us with this one really fascinating question to think about. For the past few years, the race has been all about who can build the biggest model. But if these lean, efficient, and smarter models can actually beat the giants, you have to wonder, are we finally witnessing the end of the AI arms race for just pure size?